TeamIOB is researching and trying to quantify the efficiency of the water desalinization process that we're thinking about. There are three common processes of desalinating ocean water. Maybe not common, but the first most expensive from an energy standpoint is just boiling water, heating it up to 212 degrees or 100 degrees centigrade. And then condensing it, because it takes a lot of energy to boil it, and it takes a lot of energy to refrigerate it and condense it back into water. In the 50s, early 60s, reverse osmosis was discovered, I believe, and that is quite a bit less energy, and it is a common way of desalinating ocean water now. But it does require ocean water to be pumped up to very, very high pressures to force it through membranes that the salt cannot get through, but fresh water can. Our process is the same as boiling water, but we do it in a vacuum. In a vacuum, the water doesn't have to be heated to 212 degrees Fahrenheit or 100 degrees centigrade. Water boils easily at room temperature in a vacuum. So the one problem still exists is that you can heat water pretty easily with solar energy, but the problem is the cooling source for refrigerating the water vapor back into water. Well, we realized that over the entire Earth's ocean, 3,000 feet below the surface, water temperature is always just a few degrees above freezing. So it's a free source of refrigeration energy if that water is just circulated from the depths to the surface where our process is being developed. So as a visual demonstration, I just have a pickle jar because we can see through it. And I have water here that I heated up. The temperature right now is 113 degrees. Now I've made a solar heater just in my backyard and I got 140 degrees. So I know that can be achieved. And for simplicity, I just have a cup of ice and it represents what the temperature would be of the condenser with cold ocean water circulating through the condenser. So I have this here, I'll put it inside my jar to represent the condenser inside the warm water. Then I have a vacuum pump set up. Turn on the vacuum gauge if that can be seen. Put this back on here. And I'm going to close this fitting. If we start getting a vacuum, so you can see in a vacuum, water starts rapidly boiling. Now the air is largely gone, so that's nitrogen and oxygen is gone from inside here. So the water vapor is all that is inside here now. So the energy of removing that air has already been completed. It's done. So right now, the boiling and condensation occur with solar heat, which adequate solar heat exists at the surface. But what we do is we bring up cooling water from deep within the ocean, 3,000 feet. Ocean temperature is about a few degrees above freezing worldwide. It's available worldwide. So that's what this ice demonstrates. So as you can see, the water is I can hold it with my bare hand, so it's warm, but it's not hot at all. It is cooling off rapidly because the warm water vapor is transferring to the ice. So we think this is a much less expensive way to desalinate ocean water. And I just want to be able to show that to you. So this here is the weight of my condensation water for the demonstration purposes before I'm going to boil this water in a vacuum with the vacuum enhanced desalinization process of TeamIOBs. So as you can see, it's 407 grams, and we're going to see what we have when we're done making our short video. So when I finished, the water cup weighed 420 grams, which would be 13 grams higher in weight since I started at 407 grams. So you can see we went from 407 grams to 420 grams in water desalinization in just 3 minutes, just within a pickle jar. On an expanded scale, that would be a tremendous, greater amount of water, which I haven't calculated, but it gives you the idea, and that's all I want to do right now. Video the temperature. Can you see the temperature? What is it? 80?
Yeah.
It's 93 now?
Yeah.
Can you tell me when you're going to film?
It's filming.
Oh, okay. Just when I started filming this, what is that? 3 minutes ago, maybe? This water was 114 degrees. In a vacuum, water behaves like a refrigerant, and so it cools off rapidly. So I think I'm reading 90 degrees now. So within just a few minutes, it dropped from 114 degrees to 90 degrees because it's boiling in the vacuum. That is the energy, that's the heat energy of this salt water that transferred to the refrigerant. So now that it's fresh water, that has to be pumped out, and that only is about 30 feet of head pressure, so that's really low energy in my mind, especially when you consider often in my area, well water has to be pumped up 300 feet from below the surface to get into irrigation canals. So it's 10% of the pumping energy of well water, and this fresh water could be routed to our canals all year long, and fresh water could be made off the coast of Africa, off the coast of Australia, I believe it's South America. There's desert regions that are completely arid, but this cold ocean water is available right next to the hot ocean surface water, relatively hot, so it's available year-round. And this is what I call an idea outside the box, thus TeamIOB.